going to do just some examples of the exponent rules, exponent laws. So and we'll just do a few. Let's see, we're going to start with multiplication. So let's see, our first example, we'll do and every time you see these are the things that you should be looking at. You should say, all right, here's what I'm seeing. I'm seeing that it's multiplication and that I have a like base. So when you've got like bases and it's multiplication, you know you keep the base and add the exponents. And it doesn't matter how big these numbers get. For that matter, it doesn't matter how small it gets, but we're not going to really deal with that in this class. You'll deal with that in another class. So again, we see that we are multiplying. We've got like bases. We keep the base. We add the exponents. So let's do something a little bit. Let's do x to the 4th, y to the 3rd times x to the 5th, y to the 7th. So this is one of those things where you have to sort of go back and remember a few things, and we know that when the variables are right next to each other, it means that there's a multiplication there. We just don't have to write it. So we also know that when it's all multiplication, we can completely rewrite things, rearrange things, and I'm going to rearrange this just for the sake of this demonstration. You don't have to take this step. Y to the 3rd, y to the 7th. And now we see that we've got our like bases together. So we keep our like base of x, add the exponents. Our like base of y, add the exponents. And you're done. So this works for everything. You do have to be sort of careful when you are working with multiple variables and you're including a coefficient. So I'm just going to go ahead and have 3x to the 4th, y to the 5th times 5, x to the 3rd, y to the 12th. So again, it's the same kind of deal that we did here. We can rearrange them if we want to, or we can just sort of identify them and say, okay, here's my coefficients. I multiply those. Then I go, all right, well, here's my like base of x. So I keep that x and add the exponents, 4 plus 3. And then I go to my next one. So I've got y. So I keep that base, add the exponent, 5 plus 12. And I'm done. And that's really all there is to it. The bottom line is that making sure that you're identifying what you're looking at and you're thinking about it. That's what makes it easy. If you're not doing that, you're kind of just guessing. So that said, this is our, our properties or our practice for our multiplication law. Let's go ahead and do a few with the division. We'll put multiplication, and we're going to do division now. So let's do x to the 5th over x squared. So again, we know that we have to look for things like what's going on. So we say, all right, well, we're dividing, and we have a like base, so we keep the base, subtract the exponents, and we're done. If we have x to the 12th divided by x to the 5th, again, we see that we've got a division. So we know we're subtracting. We've got a like base. We've got x and x, so we keep that base, subtract the exponents, and we're good. So again, the idea is you need to make sure that you're making the observations so you understand why you're doing what you're doing. So let's go ahead and do x to the 10th, y to the 12th over x squared, y to the 3rd. Again, we see that we've got some like bases, and we're going to make sure that we're dealing with just what's the same. I'm not that good at drawing with those. So now I'm going to go back to my x. I see that I've got my like base. I subtract the exponents. 10 minus 2 is 8. Then I go to the y, my like base, subtract the exponents. 12 minus 3 is 9, and you're done. Let's do one with coefficients. So let's have 15 x to the 20th, y to the 13th, all over 3x to the 14, y to the 8. So again, we're looking for things that are the same top and bottom. So we've got a number here. So when we have numbers, we have to remember that we treat the numbers just like we always treat the numbers. So 15 divided by 3 is 5. Then we go to the next thing that's the same. So here's our like base of x. And we know that we're dividing, so we subtract the exponents. 20 minus 14. And then we see if we've got any more like bases, and we do. We've got y's. And again, we're dividing. And when we divide, we subtract, so we do the exponents. So 13 minus 8 is 5. And that's really all there is to these. The next video is we'll do the examples of the power-to-power rule.